Okay, this is 2.6, part 2, and now we're going to talk about adding functions and determining their domain. So when we add functions, we must look at both domains, okay? So let me write that up here. FNS, functions. Okay, so when you're adding functions, you must look at the domain of both functions. It's super important. So let's look at this and see exactly what I mean. So we're going to let f of x equal x plus 3 and g of x equal, the square root of x plus 3, and g of x equal the square root of x minus 2, okay? So we're going to do two things. We're going to find a, f plus g of x, and then b, the domain of f plus g, okay? Let's just start. So let's find a first. If we find f plus g of x, we know that that is the same thing as saying we're going to do f of x plus g of x, okay? And I'm going to step down here because we don't have a whole lot of space. I wish the teacher would have left more room. That was a joke. So x plus 3 is our f of x, and we're going to add that to x minus 2, okay? That's really all we can do with that, so that's a in completion. So we're done with a. Now I'm going to kind of draw us a line here, and we're going to start on B, okay? We're going to do the work for B, and then I'll answer B down here. So we'll answer B in this color. But we're going to do B in a bunch of different colors. So first, we're going to find the domain of f of x. So he equals x plus 3, okay? So remember there's this little implied 2 up here, which means that he's an even root. When it's an even root, we set it greater than or equal to 0 and solve. So we're going to take our x plus 3, set that greater than and equal to 0 and solve. So we'll subtract 3 from both sides. That's going to give us x is greater than or equal to negative 3, okay? Now we have to put that on our number line. So we're going to have our negative 3. Why? Because we know that because of our little cheat. And we look here and it's going to be a bracket. All right? So our domain for this one equals bracket negative 3 to infinity. This little guy here. Okay. So now dotted little line. And now let's do g of x. Square root. There's a little 2 here, so we know he's even. X minus 2. So once again, he's an even root. You don't have to write all this. I'm just note building. I know you know this. Greater than or equal to 0 and solve. So we're going to take x minus 2, set it greater than or equal to 0, add our 2 to both sides. So x is greater than or equal to 2. We put him on the number line. Okay? So here our 2 is more this way than our negative 3. There's our 2. Goes the same direction. And once again, it's a bracket. So here we have our domain. Oops, I forgot our d. Is 2 to infinity, right? But we also know, we also know that when we have two functions and they're combined, that we have to look at the d of f intersect the d of g. Remember me reading that in that one little caption that I copied out of the book? So remember, intersect means what they have in common. We found the intersection before, we had to put it on a number line. So let's do that. Let's go up here and look at, let's put this one on the number line. So we have our negative 3, all right? And he goes all the way, oh, I didn't put a negative, so let me correct that, my bad. There you go, -3. He goes all the way to infinity. But we also have this guy. We have the 2, which is, I don't know, -3, -2, -1, 0, 1, 2. Here's our 2. And he's here. And he goes all the way to infinity. Intersection, once again, is what's in common. So from here over is what they share in common, right? So the domain for f plus g of x is only this area right here. So our answer for B, for the domain of f plus g, is, you always use this grouping symbol, so it's going to be bracket 2, comma, infinity. So that would be your domain. So you got to remember when you're adding, subtracting, multiplying, or dividing functions, you have to do the intersection only, okay? Right on. Okay. Now let's do composite functions. So these are composite functions. The composite of the function f with g is denoted f composed of g and is defined by the equation. So you have f composed of g of x, and that equals, this is the definition of it, f of g of x, okay? That's how you would write the definition. And the domain of the composite function, f composed of g, is the set of all x such that x is in the domain of g and g of x is in the domain of f. Okay. So I know that sounds super confusing. It's not that bad, really. Let's just look at it. So in simple terms, to find the domain of the composite function, we always look at the function on the right, okay? That's called the first operating function. So we look at the first operating function, we get his domain. You look at it, you look at the first, the domain of g, which that at this time is the first operating function. Then you look at the domain of the composite, okay? And it's always the function that's positioned on the right-hand side is your first operating function. Sometimes it can be written opposite. You can have g of f, and in this case, f would be your first operating function. You just have to read how your composite's made. But you look at your first operating function, and then you look at the composite, and then that's how you tell your function for a composite, okay? All right, let's do some. Okay, this is just a, a typed out example. So we're going to do f composed of g. So g is your first operating function in this one. Okay. F of x is 2x plus 3. G of x is x minus 7. So we're going to do the composition of f of g. So the first thing that we're going to do is we're going to write our definition, just like we always do. So the definition is f of g of x. Our second step is we just take our g of x and plug it in. That's wrong. We're going to take our g of x and plug it in for this. So we just take g of x and put it in for its, the value in for its name. And after we get the value in for its name, then we plug this in for the x, okay? So we take it in, plug it in here. So we take this amount and plug it in for the x, so then it's 2 times x minus 7. And then we just distribute. We distribute this guy in here. We get 2x minus 17 plus 3, and then we combine like terms, and then we have our new function, okay? So to find the domain of this new function, we have to look at this guy. And he's all real numbers, right, because he's a poly. So his domain is all real numbers. Then we have to look at the new composition, which is this guy, and he's a poly. So his domain is all real numbers. So for this, since this is all real numbers and this is all real numbers, for the new composite, overall Domain is all real numbers. So this would be the answer. Okay. Let's do this next one. I'm going to skip this step on y'all. I'm sorry. I'm really bad about doing that on these. Okay. So every time I do this, I rewrite these. That's me, not y'all. Y'all don't have to do it because it's right above. Okay? So let's rewrite this with its definition. So we have f composed of g. So we're going to have f of g of x. Okay? And this is the definition. And I say fog just because that's how it looks to me. My professor, whenever I was in college algebra, called it fog, or goff. If it's written the other way, I say goff. So I know I'm going to slip and say that, so I'm going to warn you guys now. So if I say fog, don't be like, what is she talking about? Because this little composed sign to me looks like a O, so I just say fog. Anyway, so the definition of F composed of G. So I wrote the definition, okay? So now we're going to sub the amounts in for G of X. So we're going to sub G of X. So I'm going to say F, or G of X is X squared minus 2X plus 6. So I plugged him in for our G of X, okay? This is why I like to rewrite it, is because I like to be able to take this guy now, and I'm going to sub him in for this X. So this line, we're going to say 3. Now we're going to put, because we're subbing this into our f of x, okay? I'm going to change colors so we can see what I'm doing. Sorry, I should have done that. Of g of x into f of x, and simplify. I don't think I can make him orange. Nope. Okay. So we're going to put x squared minus 2x plus 6. And then you can't forget this minus 4 out here. Don't leave him stranded. Now we're going to distribute this 3. Okay. So we're going to have 3x squared minus 6x plus 18 minus 4. Now let's combine like terms. Well, we only have 3x squared, so let's do that. We only have one x term, but we can combine these, right? So plus 14. Sorry, that's an x. So what did we create? Because that's as low as he can go. So we, once again, created a poly. But to check out the domain, we have to first look and see which one was our first operating system. Well, we look at the one on the right. He's our first operating system. So we look at G. Well, he was a polynomial, so his domain was negative infinity to infinity, all real numbers, right? And then secondly, we look at the composite that we just built, and his is all real numbers again, right? So we know that for the new composite, our domain is negative infinity to positive infinity. So this would be our new domain. Because we first look at our first operating system, and then we look at the new composite. So we're golden there. That's our domain. And this is our answer. Okay, let's do the next one. Let's do goff, or G composed of X. Okay. So here, our definition, speed that up some. Let me write them over. So f of x equals 3x minus 4. And g of x equals x squared minus 2x plus 6. So I can see, y'all can see. All right, so our definition is going to be g of f of x, okay? So this is just the definition. So now we're going to sub in f of x. Let's go over some. So we have g of 3x minus 4. And then now we're going to sub in f of x into g of x and simplify. I didn't put my parenthesis here. So we're going to take f of x and put it into our g of x. So everywhere there's an x here, we're going to, probably should scoot over a little bit more. Maybe a lot more. Everywhere there's an x here, we're going to plug that into it. Yeah, I'm going to scoot over a lot more. So x squared, we're going to have 3x minus 4 squared, right, for that guy. Minus 2 times 3x minus 4 plus 6. So we just took this, put it in for every now we're just going to do the math. But to do the math, we have to remember that square means 3x minus 4 times 3x minus 4, right? It means that quantity times itself. So now we FOIL. So 3x times 3x gives us 9x squared. 3x times a negative 4 gives us negative 12x. Negative 4 times 3x gives us negative 12x. Negative 4 times negative 4 gives us a positive 16. So that's going to be 9x squared minus 24x plus 16. And we're going to put this in place of him. Okay, I'm going to make a little box around this so we don't get it. Box, but you know what I mean. We don't want to get him in there. So we're going to have 9x squared minus 24x plus 16. Now we can distribute here. 6x plus 8 plus 6. And we can combine these terms. So now let's combine like terms. So we only have one squared term. But we have a negative 24 and a negative 6x, right? So that gives us a negative 30x. And we have a 16, 8, and 6. So a negative 16 plus 8 plus 6. Ooh, that would be a positive 16. What did I do wrong? It's a positive 16. That's just my copy and paste skills, sorry. So that's going to give us a positive 30. As far as we can go, right? So here we created a poly. So our first operating system this time was f. If we look at f, he was a polynomial too, so he was all real numbers. We created a polynomial, so we know our domain, once again, is all real numbers. Now this is what's so cool about building a new composite, because now they want us just to find this new composite that we found, right? G of f of x, which we found here. They want us to find g of f of x of 1. So this means we're going to take 9x squared minus 30x plus 30. And we're going to plug 1 in for all of our x's. So let's just do that. This is going to be 9 times 1 squared minus 30 times 1 plus 30. That's just going to be equal to 9 minus 30 plus 30, which is going to equal 9. So 9 is our answer. Okay. Okay, we're going to talk about numbers to exclude from the domain. So the following values must be excluded from the input of x. X is in the denominator and x is under an even root. We've already talked about that, right? We assume all real numbers and we cannot have any zeros in the denominator or any negative numbers under an even root. We know that. So if x is not in the domain of g, then it must not be in the domain of f of g. That's why we always check the first operating system. So any x for which g of x, the first operating function, is not in the domain of f, must not be in the domain of f of x. So it says the exact same thing. So let's just look at it. So I just remember get the first operating function. Domain. Okay, so given f of x equals 2 over x minus 1 and g of x equals 3 over x, find the following. We're going to find f composed of g of x, and then we're going to find the domain of f composed of g, okay? So, and we know that x cannot equal 0, right? So let's just write that over here. X cannot equal 0. That's our restriction for sure. Because if x was 0, that one would be out of here. So we know x cannot equal 0. Because that's our first operating system is g, so our g restriction is this. Yeah. So g of x restriction. Okay, let's start A. So we're going to do f of g of x. That's going to be f of g of x. That's going to equal f of 3 over x, okay? So what that means is we're going to put 3 over x in place of this. So let's do that. So we have 2 over 3 divided by x minus 1. We absolutely do not want a fraction in the denominator because I don't like fractions anywhere, but especially in a denominator. So let's get rid of that. And how we can do that is multiplying by x over x. Okay? So 2 times x gives us 2x. Now this x is going to multiply by both of these terms. So that's going to give me a 3x over x minus, that's a minus by the way, minus x. These two x's are going to cancel, okay? Now we have 2x over 3 minus x. This is our new composite. This is our f, g of x. But now we have to find the restriction for this, yeah? So let's do that. So we have 3 minus x cannot equal 0. This way to solve this one would be to add x to both sides. So, cannot equal. So 3, or x cannot equal 3, right? So let's put that on our number line. So we have 3. X can't be 3. But we have to look up here. What else can x not be? That's right. X cannot be 0. But we always assume all real numbers. So x can be anything else, yeah? X could be anything here. X could be anything here. and x could be anything here. X just absolutely cannot be 0 or 3. So here's our new composite, that's the word. Now help me with my domain. My domain would equal, this is negative infinity, this is infinity. When we're coming along on the number line, the first thing we come to is, yes, negative infinity, come to 0. Has to be a parenthesis because we're not including it, right? How do we denote a jump? Union. We pick back up on the other side of 0, and we go to 3, right on. We jump that 3, we come down the other side of 3, and we go to infinity. So that's how we would denote that. So that's how you deal with if you have a restriction in your first operating system and in your composite, okay? Is that cool? Right on. Okay. Awesome. Now we're going to talk about decomposing functions. So we just learned how to compose them. Now we're going to learn how, if we come to a problem and it's already composed, right? It's already put together, how we're going to take it apart. So we've learned together, like they're together, and now we're going to learn how to take them apart. And it's kind of cool. Yeah, I think it's really cool, but you know, I'm a mathematician, so I think most math is really, really cool. So I apologize for that. I know like y'all are like, dang, she thinks everything's cool. Anyway, the decomposition of functions is the reverse. Okay, so we're just undoing what you just learned to do, right? There's more than one way to do it. But there's often like a natural way, like you're just like, oh yeah, that's what needs to come out, and that would just be f of x. So we're going to learn to take h of x and decompose it back to where it's f of x and g of x, okay? So I gave you one here. This is h of x. I kind of typed out everything so you have something to go by, and maybe it'll help. So h of x equals 3x squared minus 4x plus 1 to the 5th power. So h takes this polynomial and raises it to the 5th power. So we can look at h of x as a composition of two functions. Right? We have this is one function, and then the 5th power is kind of the other function. So the first function, f, would be x to the 5th. So if we have g of x equals, I forgot my 3, x squared minus 4x plus 1. And I said, okay, we're going to make a composite. I want to do f of g of x, right? So that equals f of g of x. And we're going to take, different color, we're going to take this guy and we're going to just plug him into here, right? So y'all do it. Y'all just say 3x squared minus 4x plus 1, all raised to the 5th power. And because y'all are good like that, because we've been doing that for a minute now, and y'all could just bam. But then I throw you a curveball, and I say, okay, well, this new guy is called h of x because now he's a new composition, right? Now I want you to take him apart. All I'm asking for you to do is just pull this back out and write him as 2. That's what that's saying. And I know, like, you're like, yeah, that's all she's asking, right? And it's kind of difficult. So I made a fraction one because, like, for practice, because I think it's easier to see with that. So let's do that one, and maybe it's easier. So my example, here's my example. So I have h of x, x in parentheses, is 2 over 2x squared minus 6x plus 4, all raised to the 5th power. Okay, this is the way I find it the most, most easiest, that's not even a word, the least complicated to teach. Okay, here we go. What is the most complicated thing in this equation? Well, it would be this polynomial, right? So we're going to identify that. We're going to find that. The polynomial, or the most complicated thing, we're trying to find f of x and g of x. So you find your most complicated thing in your function and pull it out. So we're just going to take and pull out 2x squared minus 6x plus 4. And we're just going to borrow that from this function, okay? We're just going to borrow that, and we're going to take him, borrow him from h of x, and we're going to loan him to g of x. But we're not thieves, so we're not really stealing him. So since we borrowed him from h of x, we have to like pay something back to him, like put a placeholder there to say like, hey, we'll give him back later. So to do that placeholder, we're going to go over here and we're going to say 2. Where we took him from, we're going to put an x. That just says, that's like your IOU. I'm going to put him back, right? And then you put a 5. So that's how you decompose him. Wherever you take him from, you put an x that says, I'll put him back later, right? So now he's decomposed. Now your h of x is broken down into your f of x and your g of x. And that's your decomposition. Like, that's what you're doing when you decompose, right? And that's kind of what we did up here. Let's go back and look at this up here. I want a different color that's not the same. Yeah, pink's good. So up here we had our h of x that equaled 3x squared minus 4x plus 1 to the 5th. So we are looking for our f of x and our g of x. So we're going to look at this function and say, dang, well, obviously, not obviously. I hate it when my teachers say that. It is not obvious when you don't know it. We're going to look at this and say, okay, this is the most complicated part of this function. So we're going to borrow him and give him to g for a minute. So we're going to say 3x squared minus 4x plus 1. But now we are not thieves, so in order to show that we're going to pay that back, we're going to say x to the 5th. And that's my IOU back to him. And now he's decomposed. Because if we work in reverse like we did a minute ago, and we were to plug this back in for that x, we're going to get exactly the same thing we had. Just the way I know to teach it. And I know it's super complicated idea, but when you get it, it just like clicks and you're like, oh yeah. And I really hope that that way made it click for you guys and it made it easy. If not, please come see me, holler at me, see Chloe, whatever. But like, the more you practice it, the better it is. So in your homework, you can always go back in through your My Math Lab, reopen your homework after you're done with it. Don't hit improve your score because that'll change your homework score. Hit review and practice, and you could just hit new or similar problem, and it'll keep giving you problems until you get really good at it, okay? Because there is one like this on the test. I'll just tell you right now. Okay, so there is decomposition, and we are done with 2.6. Right on. Okay, have a great day.